Now the next topic is that of the Ohm's law in electricity chapter. Let us write a very long essay about elephant. हाथी ऐसा होता है, उसकी सूंड ऐसी होती है, उसके ऐसे दो बड़े बड़े लॉन्ग टीथ होते हैं. He is having very big ears. He is having pole-like four legs. He is having very very small tail, and he is having very little hair and whatnot. He is having very very small eyes and whatnot. All these you can write a lot about elephant. You can write thousands of the lines about the elephant. But now, how about this? If simply I show you this picture and tell you now which idea is better, to write or talk about elephant in 1,000 lines or 100 lines, or simply show you the picture of elephant, I am sure you will always say that showing a picture is worth more than million words, isn't it? So same thing is applicable to even electrical representation, circuit diagram. What is circuit diagram? It is simply representation of items in a pictorial way. Rather than writing all those things, simply express in symbols and simply drawing, just like elephant's picture. So what is circuit diagram? Technically we may write it's a pictorial or graphical representation of electrical circuit mentioning various electrical items like wires, switch, lamps, resistors, rheostat, indicators and whatnot. Repeat, what is circuit diagram? It's the pictorial or graphical representation of electrical circuit mentioning various electrical items like wires, switch, lamps, indicator, resistor, etc. And this is the example of circuit diagram. One battery is there, one switch which is open in condition is there, and a lamp is there. When you close or turn on the switch, then current will start from positive to switch to lamp and then to negative, right? Electrons will start flowing reverse side. You should remember this is the conventional direction. So battery, switch and lamp, with the help of wires, they have been connected with each other, and this completes a circuit. Circuit should always be closed path. There should not be any open, otherwise circuit will not work, right? So this is the pictorial representation and this is known as circuit diagram. Now let us talk about the Ohm's law. What is it? It states that the voltage across the conductor is directly proportional to the current passing through it, provided the physical conditions, say for example temperature, remains the same. Now what does it mean? For example, this is the conductor and these are the 2 points across the conductor, right? So voltage across the conductor, voltage drop across these 2 points, point number 1 and point number 2, is directly proportional to the current passing through it. Means more the amount of current is passing, greater the amount of current is passing through this conductor, there will be greater the amount of voltage dropping in it. Means अगर करंट ज्यादा बढ़ा तो वोल्टेज भी कहेगा मैं भी बढ़ जाऊंगा, अगर करंट कम हो गया तो वो भी बोलेगा मैं भी कम हो जाऊंगा. Means V is directly proportional to I. Directly proportional sign is clipping 8, right? Clipping 8, अगर मानो कि 8 को ने सुला दिया, इंग्लिश 8 को, तो ऐसा तो दिखेगा. So voltage is directly proportional to I. Mathematically it may be written V is directly proportional to I, so V by I is always constant. It has been seen that if we divide the value of voltage and value of current, we are always getting a same number. For example, voltage 10 है, करंट 5 है, तो हमको हर बार 2 ही मिलेगा. वोल्टेज 20 है, वोल्टेज 20 है और करंट मानो कि 10 है, we always get 2. Means the division of the ratio of voltage and current is always constant, and that constant term we represent it as the resistance. So more properly we may write mathematically this equation as the famous equation V is equal to IR. So this is known as Ohm's law, and its graph is something like this. As you go on increasing the current, voltage will keep on increasing, right? So this is the graphical representation of that mathematical equation. And these are the three equations which you will have to remember in mind, that V is equal to IR, and from this equation we will get the value of R is equal to simply changing V and I, that is V by I, and I is equal to V by R. Next, let us talk about the resistance. So resistance R is the opposition to flow of current. It's constant for a given material. It varies from material to material. For example, it will be different in gold and different in copper. It varies from material to material, but it will remain constant for a constant material. For example, if you take a rod of iron of 1 meter, it is having, for example, 5 ohms. Now you take another rod of 5 meter having same dimension, it will also have the same resistance. But if you are having same rod of copper, you will have different number of resistance. So resistance R is the opposition to flow of current, and it's a constant. It is having a constant value for a given material. Its unit is ohm. Symbol is something like this, just like a bump. Means if you are passing on a road, sometimes you feel a bump is there, your vehicle will just be like this, right? So a bump will be there to stop the speed of vehicle, to reduce the speed of the vehicle. Same way, this electron speed, the amount of current will get reduced with the help of bumps. In our technical language, we'll use it is a resistance. Material having very low resistance are generally used as conductors in our house for wiring, etc. For example, copper, aluminum in transmission lines. You may wonder that why aluminum is there in transmission line and not in our home, because copper is a good conductor of electricity and it is widely used in our home. But aluminum, it is little bit cheaper, so it is widely used in transmission lines because a huge amount of wire is required in case of the transmission lines. Material having very high resistance are known as insulator. For example, rubber, wood, PVC, etc. But do you know which is the best conductor? Just pause a video, stop a video and think. Rutwa, can you answer which is the best conductor of electricity?
Silver.
Yes, she is right. It's a silver. Silver is best conductor of electricity. Then you may wonder, why don't we wire our house with silver? Why? Because it is a good conductor of electricity. Why don't we wire with the silver? Because silver is very, very costly metal. And one more thing, while doing any practical application, we will have to see whether it is cost effective or not. If we are using silver, does it save sufficient amount of expenditure or cost while we invest it? So silver is too costly. It does not return the amount of our investment. But copper at a time is very cheap and it is very useful. Anyway, again I am reminding you will have to remember this equation, R is equal to V by I. Now factors affecting the resistance of any item. As I already said, that resistance is opposition to current. So longer the conductor, long will be the resistance. Technically word, we may say directly proportional to length, means longer the resistance, higher the amount of resistance will be there. And if we are providing larger path, then it is inversely proportional to cross-sectional area of conductor. In practical words, in easy words, we may say, if we increase the size of conductor, there will be now more space for electrons to pass through it. Now they can easily pass, right? If we are having very small cross section means यहाँ पर कट कर दो, आप देखो कि इसका cross section कितना. For example, इसका cross section length into breadth. This is the cross sectional area, right? And so this is having very small cross section. The number of electrons which can pass through it will be lower. So resistance of this will be lower in comparison to this. Means greater the cross, अगर बड़ा पाइप होगा तो उसमें से ज़्यादा पानी जाएगा. छोटा पाइप होगा तो उसमें से कम पानी जाएगा। मीन्स ये हम समझ सकते हैं कि बड़े पाइप वाले क्रॉस सेक्शन एरिया में से ज्यादा अमाउंट ऑफ करंट विल बी एबल टू फ्लो, मोर अमाउंट ऑफ करंट विल बी एबल टू फ्लो थ्रू द बिगर कंडक्टर हैविंग बिगर क्रॉस सेक्शनल एरिया एंड lesser amount of current will be flowing from the conductor having lesser cross sectional area. So mathematically we may say resistance is directly proportional to length of the conductor but inversely proportional to the area of the conductor, and summarily we may write R is directly L inversely A, and if we remove the constant then we will get a proportionality constant, that is rho, RHO. So R is directly proportional to L by A. So mathematically we may say R is equal to rho L by A, where rho is constant for any material. Now rho is used to denote the resistivity. It, as I already said, that just like resistance, it also varies with the material but it remains same for a material. Alloys have generally higher resistivity, so they are widely used in heater iron. For example, nichrome, an alloy of nickel and chromium. It is having very high resistivity than nickel as well as the chromium. So it is used in heater, electric iron for ironing the clothes, etc. But at the same time, metals like copper and aluminum have lower resistivity, so are widely used in conductors and wires. Which metal is used as a filament of a lamp? Can you answer? Just wait. Just stop the video and tell me. Just write in a comment which metal is used as a filament of a lamp. It's tungsten, W. Now why the symbol of tungsten is W? Because its German name is Wolfram. Wolfram, though W is coming from there, so it is known as Wolfram or tungsten. Tungsten is used in the filament of a lamp, and neon and argon gas are also kept inside it so that there is no reaction between the, or say no oxidation of filament takes place. It lasts for a long. Now let us see the resistivity. You can see that there are three conductors: silver, copper and aluminum. Silver and copper are having almost similar resistivity, so it's better to use copper than silver, right? Cost will be quite low, very low. At the same time, there isn't very much high difference of resistivity. Aluminum, it is having 2.63 into 10 to minus 8, but see the resistivity of alloy of nickel, chromium, manganese and ferrous, that is nichrome. The alloy nichrome, which is the alloy of nickel, chromium, manganese and ferrous, it is having 100 into 10 to minus 6 ohm meter. Resistivity is expressed in ohm meter. And now see the insulator, rubber, it is having resistivity of 1 into 10 to 15 ohm meter. Okay, so these figures you need not to remember, they are just for your reference, that conductors are having lower resistivity, alloys are having much higher resistivity than the conductors, and insulators, they are having extremely high resistivity. Thank you.